Alright, so this tutorial over here, I just continued on with the last one from copy pasting the rivets from the left side to the right, so the right side to the left side, and I just did the same process to do the rivets on the top and the bottom. What I would like to do in this particular design is actually try to get this to start simulating. So, well, firstly we're upside down. So we're going to actually simulate the um, how the object is going to be lifted up through this. So the first thing I want to do is I actually need to make like some sort of location, because some sort of what's it called? We need some sort of metal rod or something where we can have a pulley, so we can actually start to get a force to go through this. So we're going to be drilling another hole into here. I'm just going to try to think of where is a good location. We might want to actually replace. Do we want to replace that rivet, or actually we'll probably get another spot over here. Looks nice. So what I'm going to do is I'm going to sketch over here. For this particular sketch, we are going to show hidden edges, and I'm just going to guess a particular circle here. Let's go and just assume it's like 4 millimeters. So then I'm just guessing all these. We'll worry about its logistics later. Let's say we want to do a hole. We want this, and we want this hole to go all the way through, because this is going to represent a lifting device. And then let's go. So that's 4 millimeters. Is that enough? I think we might actually have to make this hole bigger. So let's actually go over here. Instead of 2 millimeters, let's change this to 4. Okay, let's make it larger. And then let's get a nice large alright, and let's go and let's just extrude this. Let's go and change how long, the extent we want it to be to an object. We want it to be to there, and this one we want to make a new body, and we have to make sure this one is going to be this over here is going to be, what is it going to be? It is going to be steel, because we need it to be nice and strong. So we're going to physical material. We will make this. Is this steel? I assume that's steel. Yep, steel. Okay, close. And can we? Let's see if we can get a point. Construct. Can we get a point along a path? Do you have a path along here? No, we don't. We want a we'll see if this works. We'll just put the force on the whole beam. All right, so that's where we're going to be. That's where we're going to be getting our lifting device. Next thing, so we have all these rivets. So is there any way we have to see if we can? We're going to want to start to group these things together. So what we will do is right click. We want to make a folder. Hold up, I'm going to pause it. Alright, so over here on the side, we have a lot of bodies now, and it's going to start to get confusing for us to pick each individual body. So we're going to put these into groups. to assist us in this design. So if we click over here, and if we hold the shift button, we can click through, and all these bodies are all the aluminium parts. So what we're going to do is we're going to do that, and we're going to right click, and we're going to move it to a group, which should make, it's going to be a group, yep, and then the target group, we have to make a group. Click all these bodies again, right click, and then create. Is it selection set, or we can go and move to group? Our target group is you have to pick something to put it to make it go to. Something happened. Not named views. Oh, correct. Sorry. Make a new group, and in this group over here, we want to call this. We're going to call this Truss. Or we can just call this aluminium. Aluminium, and we just want to get all these bodies that we have here, and we're just going to drag it to here, and so now we can select that whole group there. These parts were failures, or parts not failures, but these are parts that we want body one. These parts over here were parts that we did previously before I did the riveting, so I'm just going to delete those, remove those. Okay, and these are our cross-section members. Basically, I want to pick everything before we start getting to the rivets. And okay, so not this one. 53 is a rivet, so it's aluminium. Let's make another, right click, let's make a new group. Let's make this called rivet. Oh, what's happening? Group 2, rename. Rivet. And over here we have this. See how they're highlighted in blue, so alright, so these go there, and we put that into rivets. What do we have over here now? These look like the members on the other side. This over here looks like a rivet, so aluminium, and over here this looks like a rivet again. Right, so I believe if we do this, if we hide this, we can see all the parts, and then if we hide all the aluminium, we get all that, and we sort of, where this body is, oh, that's not a rivet, that last one, I think. That is, how do we want this to be, how do I get that out of there without scrolling? Right click, I should say move to group. The group I want to bring it to is bodies. Okay, so it should be, so I can hide my rivets and it should be down there, cool. Alright, so can I actually rename this entire section? Let's go over here. Open. Can I right click? Can I right click, create a selection set. So now that means I'm going to select all the rivets. Now let's go and put this into the simulator. So let's save it, and this one over here is Truss Simulation Full 3D Rivets. Save. Yep. Cool. Let's go and go to simulation. We want to do a new study. Static. This particular one, this is study 3. We don't actually want these previous studies because delete. Yep. Delete. Yep. Right, so what we want to do is we want to simplify our design first, because there are some parts that are overlapping, and simplify will fix that. We then want to, we have our materials set. We want to do our contacts. We want to get the system to automatically detect all the contacts. Right, this is going to generate, and this is going to find all the individual contacts. Then what we're going to do is we're going to disable the contacts that are not relevant for us. So for example, everywhere there's two pieces of aluminium, these two pieces are not actually going to be connected together. They're not glued together. They're connected by this rivet. So what we're going to do is we're going to go to manual contacts. Sorry, not manual contacts. We're going to look at, we're going to manage the contacts, and it's going to load up a big file over here. Does it expand? No. Alright, we need this to be much larger, so let's make it use the whole screen. Alright, so these are all individual contacts. So let's look what a contact looks like. If we look at contact 1, which is bond 1. I know the number in order is weird, but anyway, bond 1. If we look at this over here, this is connecting body 83 to body 110. Now I think if we select it, we can see over here it's connecting. This face over here is connected to this face over here, which is the back of the rivet. Right? Okay, that's a bit of a boring one. Let's see if we can find one that's let's see if we can find another one. Let's see if we can find this bond over here. What's this connecting? What do I want? I want something like in the 70s. No, I want something that's everything's below 50s, because I know that's going to be good numbers. I'm just randomly going through the numbers. What are you? No. No. Oh. Alright, here's a good one. Okay, so this over here is the, what is this? This is the face inside this piece of aluminium here, and it's connected to this face over here. So there's a joint, it's saying that these two pieces are glued together, this place and this place. Right, if you click it, it's going to show, it's the body number 2, which is that whole piece of aluminium, and that particular face is just that part that's highlighted in blue. And body 51 is that one over there. So that is the body, and it's a bonded, which means it's connected together, right? And it's symmetric, so it works in all ways. What we can do is we actually don't want these. So what we're going to do is we're going to go to, how do we hide these? We will collect, we're going to go to, instead of doing by list, we're going to do it by bodies, and then we're going to press we're going to select all the bodies right now, right click, and then we will, we want to disable some of these bodies, so just hold on. Right, sorry, we're back. So you have highlighted all our individual bodies, and what we're going to do is we're going to right click, and if we press right click, it's going to say suppress contacts on selected bodies. So basically we want to hide every single joint on these members is suppressed. If we go over here, we say that bond is suppressed. Then what we're going to do is we are going to find our bodies that relate to our rivets. Right? So how do we find those rivets? We can go to our is it our construction? If we go no, not construction, model components, bodies, are they named? If we have to do this all manually, it's going to be quite the annoying scenario. So we don't want body 1, body 10. So I believe the one thing we have to our advantage is that the bodies are if we hold on, let's hide the things we don't want. We don't want body 1. We can hide you. And why are these not in alphabetical order? That's what I really want to know. We want to hide all the, let me just select this in freeform. We want to hide, what am I doing? Right click, hide, and then we want to how do we select all these things now? Right, that works. We can select it like this. Nope. Yes. Right click, hide. We don't want this. Right click, hide. Right, that looks like everything. So these are just the rivets. If we go to components now, we could look at just the things that are not hidden. Right? Or is it not? Where are these? So what I've done here is these are just the rivets. Right? If we highlight the rivets, we can see there these bodies over here. And what I did is I right clicked and I pressed isolate, just so obviously it says unisolated. But I just said isolated so we can see that they're the visible ones. So when we go to manage contacts, we can go through and we can see which numbers we need. So we need 53 to 69. So let's go to the 50s. And so what we're going to do here is we're going to press 53, and I'm holding the shift button, 53, 54, no, that's 100, sorry. We want, can I get this larger, please? Fifty, 53, 4, 5, 6, 7, 8, 9. And we're going to right click and we're going to say, these are, oh, hold on, those are the suppressed ones, right, unsuppressed. So actually what we want to do is we want to press the entire, we wanna go through and we want to get all the members. So all the joints. Scroll all the way down to the bottom, click them all, right click, suppress them. So they're all suppressed. And then let's go look at 50. We want 53 all the way to 69. So it's 59. So 53 to 53. And just because the way these numbers are, 59. So then we want 60. No, not you. 61, 62, 63, 64, 65, 66, 69. Alright, and then the next ones we want are number 84. We want 84 to, that's a big one now. 84 to 122. So there's 84. And 1, 2, 3. Where's 100s? Oh no, this is a mistake. This is a mistake. These are the bonds. We don't want these bonds. We're going to go back to bodies. Oh, we'll have to do this again. So over here, these are joints. We don't want that. So let's actually undo what we did here. And we pressed everything. We want to go through. Let me just press everything. Right click, unsuppress. Okay, we're going to do it by bodies. My mistake. Alright, so let's go through. Let's select all the bodies. Right click, suppress contacts from these bodies. Let's go where we were again. We're body number. The bodies we wanted were. We start with bodies. It was 53 to 69. So that, and then we want that and that. We want to right click. We want to unsuppress those ones, and then the other ones we want is 84 all the way to 122. So 84, where are you? 84, we'll go to here. '84 to where were we? That was 90, so it's any one of these big numbers. And we actually do want 1, 2, 3 because that's going to be the final bar that everything's going to be connected to. So we have these, and we can right click and we can unsuppress these contacts. So if this all works well, we should see things like body 11 over here is going to have part of its bonds suppressed, which these are the ones connecting the pieces of aluminium to each other. But all the bonds where the rivets are, they are going to be not suppressed. So now what we've done here is we've got our object and we're just connecting it by the rivets. Okay, so once this loads up, let's go and go to the next step for this advanced design where we're going to adjust our mesh. But I'll pause the stream and then unpause it when this loads. Alright, so my thing froze. I redid it again later, and so this time it worked. Just as a bit of a note, if I was to do this design again, what I'm noticing is this lovely design of rivet over here actually produces an unnecessary joint, like a connection, contact. I'll just make it a simple rod going through next time. But, okay, we have this thing, that's all good. Let's go, our next thing we're going to look at is our mesh, where, let's go and hide these members so we can look at this side. If we look at our mesh, if we press the view button, mesh has not been configured. Yes, please give me a mesh. Over here it should start designing a mesh, and this should be a very simple mesh. I'm just going to pause it and undo it once it's generated. Nope. Sorry, we're back. So over here, as we look at these triangles, we see here now we get a much more triangles, or a much better mesh around the circular points. But it still stays relatively large around here. The total number of meshings you have will relate to the how long this design is going to take to be made. Then let's go and do our standard constraints that we did previously, where we're going to just do a fixed structural constraint, and we'll do a constraint down. We'll do a constraint. We'll do this base and this base, and let's just say this. Let's just say for this scenario that these four members are glued onto the ground, and then we will press OK, and then we will go to our rod over here, and we want to give this a load. Let's say it's a structural load. We want to press this whole tube, and let's say this tube is just going to be going. Let's say it's or 25 kilos is 250 newtons. And do we have an angle that we want it? We want it to go like this, minus 180. Alright, so this should be enough information for this thing to run. If we do pre-check, has unconstrained groups in load case 1. Oh, because we haven't done automatic contacts. Wait, what's wrong? Let me just simplify this workspace. Simplify. Press simplify. That should have fixed some of the things. I don't think anything else is wrong. Is there an auto simplify function? What else is necessary? Yeah, okay, visibility is fine, fine, fine. Contains one fully unconstrained group. Let me just see if I can check this. Alright, the only problem I had to remove the base that was there. So now we should be able to solve. And this particular one, oh, I only have a certain amount. Let's see if I can do this locally instead. Let me just fix that interferences as well. Alright, I'm just running the test, and I'll resume once the test is done. Alright, we have gone and finished the analysis, and well, looking at here, the obvious failure point is this bar over here. But we'll ignore that for now because we might have to fix that design later. But let's look at the actual structure itself, and the structure itself seems to be able to handle 25. We said 25 kilos was our original analysis, and the let's if we hide, I'm pretty sure we can hide this body. If we hide this body, does it show us the next highest? I think it does. Okay, if we hide this body, we can find out where the next maximum and minimum is. So the factor of safety, the next factor of safety is over here where these bolts are, over here, somewhere this bolt inside here is an issue. In fact, if we hide, can we hide this? Right click. Hide. Can you please hide? Nope. Undeformed, please. I want to. Why can't you hide for me? Let's have a look actually. Let's see if under our deformation, let's actually see what happens. Does it flex in 3D? Not so much, no. It's still mostly a 2D deflection. The factor of safety, so minimum 0.75 means that this bolt over here is going to fail. So if I was to design this particular crane structure again, I may either have to put 2 rivets over here, or maybe put a piece of metal that is double thick there. But the rest of the structure, like the only place there is stress in these structures seems to be where these rivets are. These particular designs have the whole rivet over here, so I might actually, like if I can hide one of the rivets. That's got nothing on it. Can I? Are you going to be able to show me this? Close, please. Let's remove like these ones over here. Alright, so if we zoom into over here, we can see that it's like inside here is a connection where it's producing a bit of stress. Let's have a look at the stress, see where the maximum stress is. So it seems like the maximum stress is 275 megapascals. Looks like it's inside that pop rivet, so yeah, that's the area where there might be a failure. So I would reinforce this top section. These cross members over here have the least amount of stress, which as we've already determined. If we just look at the color of the actual members themselves, and we see there's darker blue, a bit annoying how this, there's darker blue all throughout this midsection. This is almost zero stress is being transferred through this middle section. In an ideal scenario, there should actually be zero stress here because if it's perfectly symmetrical. But in a non-ideal scenario, there might be some stress. It's still going to be much less than the actual stress traveling through these beams here. If we look, this is like the light blue section. So these seem to be getting like 60 megapascals, I assume this is in? Yeah, MPa. This is about 60 megapascals is going through the shaft over here. We have over here seems to be a bit more, so 60, but then the most stress seems to be inside where, like here, where these joints are connected together. So we might have to do some extra consideration when we design those. Alright, that's it for this particular tutorial of this lifting device. Next tutorial, I'm going to show you another design variant, and so we can try to get some comparing and contrasting for those. Alright, so this is a long tutorial. Thank you if you paid attention throughout the whole thing. Alright, see you later.